So this question is the first one there in the arrays, and it's find the element that appears once in a sorted array where all other elements appear twice, one after another. And they want us to find it in big O log n complexity. So basically, our sample input is going to have pairs of numbers. However, there's going to be one number that won't have a pair. So our expected output will be 4. So given that we have a sorted array, we're going to be able to use a binary search. And so we're going to, since we have a sorted array, we're going to use binary search, and we're going to find the first, or we're going to find the non-paired element. So considering that every other number is going to have a pair, that means they are going to be, the pairs will make an even amount. And then our non-pair is going to make the array size be an odd number. So basically we know that each pair has a start and an end. It has a start and an end, start and an end. And for example, with 3, our end is going to be, when we look at it, it's going to be kind of like an odd index, and that's where let's see, 0, 1, 2. Actually, it's going to be an even index. So basically, where our pair number starts, it's going to be an even index, even. So that's a 2, and it's going to end at an odd index. This is an index 3. So basically, that's how we're going to kind of modify a bit our binary search, so that we know which way we're going to look. So basically, at the even indexes, the pair of the elements, they're going to start, they should start, and odd indexes, the pairs would end. So when the mid of our array happens to be even, that means that our pair would start, correct? And so I'm going to check my right side, and if our mid happens to be odd, I'm going to check the left side. And basically I'm gonna check the output of that given side, to make sure that it actually is paired together. So let's start. So I'm gonna do this in JavaScript. So we're gonna start our function, and it's gonna be called find non-pair, and it's going to take in an array, and from the get-go we're going to initialize our lows. So we're gonna have our low, which is gonna be 0, and we're going to have our high, which will be the array length. The array length -1, and we're going to get our middle. So let's get, we're going to get our middle. I'll just put mid, and basically we're going to get that mid by adding our low and our high dividing it by 2, but we're going to make sure we floor it so that in the case that we have okay, so that way we don't get like a decimal amount and we round down. So now we have our low and our high, which are basically pointers, and we're going to do this while they do not intersect. So while our low is smaller than our high, we're going to actually I guess I could have calculated the mid here. So let's actually move that middle here instead, because we're always going to be calculating our middle, getting a new middle every single time. So let's do that instead here. So let me erase this. So I declare it, and now I'm going to give it a value. So let's follow that same what we had previously, which was low plus high divided by 2. Okay, so now we're going to now start checking. Now again, if it's like reiterating, like if it happens to be, if our mid happens to be an even number, we're going to check the right side, and if it's an odd number, we're going to check the left side. But we're going to also kind of like update our respective lows or highs depending on which side we're going to be checking. So let's start. So let's say, so again we said if the mid is an even number, we're going to check the right side. So we're going to check right side, and let's do this. We're going to check if mid, so we're going to use modulo to check if it's an even number. So if it's if our mid modulo 2 happens to be 0, that means it's an even number. So we're going to check the right side, and while we're there, we're going to check. So again, if it's an even number, we're going to check that the number on the right side is actually in fact the same number, correct? So let's check that. So if array mid equals array mid plus 1, because we're going to check the next index, the value of that x index, we are going to so if it happens to equal, then that's good, right? If it's the same, but now we're going to get a new low, and considering again, since we know that pairs come in twos, the reason why we're checking the right side is because on our left side, there's always going to be a pair amount of numbers because our middle happened to be even. So the number that happens to be the number that happens to be singled out will be on the right side as opposed to be on the left side, because our middle, well, I guess if this is our middle, I haven't calculated the middle here, but that was just an example. So let's see, 0, 1, 2, wait, 1, 2, 3, wait, 0 plus our high, which is, what was our high? Our high we calculated by getting the length. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 minus 1 is 10. 10 plus 0 divided by 2 is 5. So 0, 1, 2, 3, 4, 5. So in this case, this is our, this happens to be our mid. And again, since 5, 0, 1, 2, 3, 4, 5, 5 is an odd number, that means we're going to check the left side. And that's where eventually we're going to find it once we continue this. So now we're going to, we have to get a new low, because when we check the right side, we're gonna move our left pointer towards the right. So our low is gonna be different now. So since we already checked the next index next to the mid to make sure that it was equal, we can move our pointer 2 spaces. So it's going to be our mid plus 2 will be our next low, and that's done for that one. And if not, if our mid doesn't have to be an even number, then that means we're going to check the left side. So check left side. So we're going to check the left side. Oh, actually this, so this actually is for this specific. So in the case that it doesn't happen to equal, we're gonna check the other side, and we're going to now get a new high. And our high basically is going to be our mid now, because we're going to evaluate the other side instead, or we're going to move like to the other side, since it didn't happen to be on that specific side the number. So our high would be our middle, which is called mid. And now we are going to now check the left side. So check left side, and again we're gonna check, since now check the left side, and we know that it's an odd. Middle is an odd number. So now we're going to check the left side. So if array mid equals array mid minus 1, we're gonna get a new low. Get a new low, and our low is going to move, is gonna move up. So it will be our mid plus 1. Low equals our mid plus 1. Since in this case, it was an odd number, we're just moving 1 up. Okay, so we have that, and now we also, in the case that it doesn't equal, that means we're gonna like get a new high now. So our high will be our mid minus 1, or mid minus 1, and let's see, so this one goes with this one. Wait, I think I'm missing a bracket. I think so. Yeah, and yeah, because that was for this one, and now I'm missing the one for the while loop. And so once we you know, go through the array and always dividing, like dividing and conquering our problem, at the end we're going to just return one of our ends. So we're going to return our array low, and that would be it. That would be big O of log and complexity, because again we are always dividing our problem by half.